Module 3, Data Preprocessing and Feature Engineering. 3.1, Data Cleaning and Transformation. Importance of data quality. Data cleaning and transformation are crucial steps in the machine learning pipeline as the quality of input data directly impacts the performance and reliability of the resulting models. Common data quality issues. Missing or incomplete datasets often contain missing values due to data collection issues, system failures, or human error. Noisy or inconsistent data. Data may contain errors, outliers, or inconsistencies that can affect the learning process. Duplicate or redundant data. Datasets may include duplicate or redundant records that need to be identified and handled appropriately. Data cleaning techniques. Handling missing data. Strategies for dealing with missing values include removal, if the missing data is minimal, imputation, filling in missing values based on statistical methods or domain knowledge, or using algorithms that can handle missing data directly. Outlier detection and treatment. Outliers are data points that significantly deviate from the norm. They can be identified using statistical methods, e.g. z-score, interquartile range, or domain expertise. Outliers can be removed, transformed, or treated as separate cases depending on their nature and impact. Inconsistency resolution. Inconsistencies in data, such as varying formats or conflicting information, can be resolved through standardization, data merging, or manual correction. Data transformation techniques. Scaling and normalization. Scaling brings features to a similar range, e.g. between 0 and 1, while normalization adjusts the data to have a mean of 0 and a standard deviation of 1. These techniques help improve the convergence and stability of many machine learning algorithms. Encoding categorical variables. Categorical variables need to be converted into numerical representations for most machine learning algorithms. Techniques include one-hot encoding, label encoding, and target encoding. Handling text data. Text data requires special pre-processing steps, such as tokenization, splitting text into individual words or phrases, stemming or lemmatization, reducing words to their base or dictionary form, and removing stop words, common words like the or and. 3.2 Feature Selection and Extraction. Importance of feature selection and extraction. Feature selection and extraction help identify the most relevant and informative features for a given machine learning task, improving model performance, reducing overfitting, and enhancing interpretability. Feature selection techniques. Filter methods. These methods assess the relevance of features independently of the learning algorithm. Examples include correlation-based feature selection, chi-squared test, and information gain. Wrapper methods. These methods evaluate subsets of features using the performance of a specific learning algorithm. Examples include recursive feature elimination, RFE, and genetic algorithms. Embedded methods. These methods perform feature selection during the model training process. Examples include L1 regularization, lasso, and decision tree-based feature importance. Feature extraction techniques. Principal component analysis, PCA. PCA is an unsupervised method that linearly transforms the original features into a lower dimensional space while retaining the maximum amount of variance. Linear discriminant analysis, LDA. LDA is a supervised method that finds a linear combination of features that maximizes the separation between classes. Autoencoders. Autoencoders are neural networks that learn a compressed representation of the input data in an unsupervised manner. The learned representation can be used as extracted features. Domain-specific feature engineering. Feature engineering involves creating new features based on domain knowledge or insights from data exploration. Examples include creating interaction terms, aggregating features, or extracting specific patterns from text or images. 3.3 Handling missing data and outliers. Missing data mechanisms. Missing completely at random, MCAR. The probability of a value being missing is independent of both the observed and unobserved data. Missing at random, MAR. The probability of a value being missing depends on the observed data, but not on the unobserved data. Missing not at random, MNAR. The probability of a value being missing depends on the unobserved data, which can lead to biased results if not handled properly. Techniques for handling missing data. Deletion methods, listwise deletion, removing entire records with missing data, and pairwise deletion, using available data for each analysis. are simple approaches but can lead to loss of information and biased results. Imputation methods. These methods fill in missing values based on the available data. Examples include mean, median or mode imputation, regression imputation, and multiple imputation, generating multiple plausible values for missing data. Advanced methods. Machine learning algorithms such as k-nearest neighbors, KNN, or decision trees can be used to predict missing values based on patterns in the available data. Outlier detection and treatment. Univariate methods. These methods identify outliers based on the distribution of a single variable. Examples include using z-scores or the interquartile range IQR method. Multivariate methods. These methods consider the relationship between multiple variables to identify outliers. Examples include Mahalanobis distance and local outlier factor, LOF. Treatment options. Outliers can be removed if they are confirmed errors or anomalies, transformed, e.g. using logarithmic or Box-Cox transformations, or treated as separate cases for analysis. This module covers essential techniques for data preprocessing and feature engineering, which are critical steps in preparing data for machine learning tasks. By understanding and applying these techniques, practitioners can improve the quality and relevance of their input data, leading to better model performance and more reliable results. The module emphasizes the importance of data cleaning, feature selection and extraction, and handling missing data and outliers, providing learners with a solid foundation in these areas.